Hello everyone, welcome to this yet another tutorial of the carbon updates dashboard. Today we are going to talk about how to solve tasks that will help you solve the calculations behind what goes inside a carbon credit and sort of demystifying the carbon credit idea, how to calculate it, how does that whole operation work, and how does that whole calculation and that policy supply chain work. We are working with the carbon updates dashboard. So without much further ado, let us begin. So whenever we begin, as we've seen in our previous tutorials, and if this is the first one that you've seen, this is your welcome screen. Whenever you log in, this is what it show you. In the background there is a little bit of a map, there's a little bit of a shadow over there, but whenever you get started, what's gonna prompt to you is a country selection tool, right? So usually we would like to select Nepal as a country because I'm from there and I find it most comfortable, and then it loads Nepal's map in the background as well. So this is the map of Nepal with the global forest watch that we've loaded, right? So let me give you a quick a run through of all the tools that are available. We have the map view. So map view basically means if you click on the map view, it's going to give you the map and you can change the layers of the map. There's the project view, which you can only access if you are a registered user. So we're going to talk about that a little bit later. We're going to only talk about the free tools that are available. The project view is for those people who have actually registered a carbon credit project or who are in line to register their carbon credits and receive those carbon credits, right? This is only possible if your country or your locality, the political boundaries, they have made a formalized policy that affects throughout your country, or at least throughout your geography, right? So it's a political issue. So if you're watching this from some other country where it's not applicable, it's not applicable. But in Nepal, it is one of those countries that is foremost in terms of publishing climate change policy. So in Nepal, it's more applicable. That's why we have more set of tools available in Nepal, right? Then there is the layers option. This is basically your mini app store, and you can switch around and choose your tools. Right now we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16 tools available right now, right? So we're gonna talk about this more and utilize this more. We've already gone through the base working map in our earlier tutorials, and we've done the drone mapper software, we've done carbon price estimator, we've gone through global forest watch, we've done this Bipat portal, we've done climate simulator. We haven't done economic complexity yet, right? But we've done the IPCC database. We haven't done weather prediction. We have done carbon pricing, and we are going to do inventory comparison in someday. But we've already explored NDC dashboard and BTR dashboard, and we already know what the 3D visualization looks like. It's just a portrait map right now, and it's just showing you this 3D visualization. So this is actually close to what we're going to learn today, what a task is and carbon estimation tool and everything else related to that. Other than that, I'm going to give you a rundown of the info button again. This is the info button. Whenever you press on the info button, you get tasks whenever you are logged in, but here you get a description of the dashboard. This platform helps manage carbon finance projects through a collaborative workflow involving multiple stakeholders, right? We have user roles, we have project developers that creates and manages carbon projects, we have verifiers that reviews and verifies project details, we have financiers who provide investment analysis and funding decisions, we have government stakeholders that provide final or approved rejection of different kinds of projects, and we have super admin who oversees the content and project workflow and the system design of the whole entire system, right? So full transparency within which how the user roles are performed. So we have project workflow. Project flows through verification, financing, government approval stages, with each role having specific responsibilities and tasks. So if you want to log in and go and do that, that is available to you. You can change country. You can go from Nepal to Sri Lanka, and we're gonna expand into one of these other countries pretty soon, but it depends upon how well they are performing, right? And we have the chatbot. Chatbot is available for our logged in users because it uses different kinds of API keys to connect with the superbrain, either whatever kind of model that you want, and for that it will cost us money to do that, right? So this is available for logged in users, and login button is available for login users. We also have the search button, right? The search button is useful for running in the project view, and there are mostly buttons that are useful for people who are logged in. But now, right, if you want to log in and you want to sign up, so basically what you do is you do sign up over here, and then you have different kinds of subscription plans, right? You have $10 a month for individual project developers, you have premium tier for mid-sized project developers or verifiers, right? And then you have enterprise tier for large scale project developers, verifiers, and the whole package for a project developer, verifier, and financier. The whole team can accommodate with this. Then the government tier can have like the whole packaging. You have the tranche of project developers, verifiers, financiers, and the government stakeholders all packed into one for this, right? So we don't have to do any of this. You can literally go to www.carbonupdates.com right now and use any of the tools I'm going to describe to you today. But whatever reports that you generate from these tools, right, you have to input it somewhere whenever the policy comes into your country. Whenever that happens, this website's login features are available for you. And if you are part of 1, 2, 3, 4, 5, 6, 7, any of these countries, then you can absolutely utilize this software login features currently, like right now. You go in and utilize them right now. For that, you just have to sign up. So without much further ado, at 6:56, let's begin. So today, what we are going to do is we are going to tackle the first issue that most people see, the GHG emission calculator. If you don't know what GHG means, GHG means the Global Greenhouse Gas Protocol, right? Greenhouse gas emissions, right? So greenhouse gas emissions is the GHG protocol is maintained by the GHG protocol corporate standard, right? And there is ISO 1464-1 column 2018. This is the standard that operates and controls this calculation mechanism. We have the IPCC guidelines, and we also use EPA emission factors to calculate all of this, right? So basically, GHG emissions is dropped down into three major areas. As you can see, we have scope 1, which is the direct emissions. For that, we have a calculator that calculates all of these. Then we have scope 2 that calculates the energy demands and indirect energy emissions, and we have scope 3 that calculates the GHG inventory based on your value chain. So this was developed by the GHG protocol corporate standard. I know there is different kinds of definitions between, like there's subdivisions between 2A, 2B, and 3A, 3B, but you can go through that route, but this is more of a beginner to expert friendly, so you can estimate up to whatever you can do that. And when you want to take this estimate to a higher performing tool, we're going to talk about that a little bit later in one of our other tool, which is the verification tool selector. We're going to talk about that a little bit later. So let's just talk about the GHG emission calculator, right? And then you get the summary. That's basically it. You go 1, 2, and 3 and total emissions, and you get a report, and you can export or download the report into that. So let us start, right? Whenever you're talking about direct emissions from sources owned or controlled by your organization, or like that particular topic that you're searching up. So let's say you have a stationary combustion. Stationary combustion means there is combustion happening in terms of heat, or some way you are burning things, right? So what is the fuel source that you use to burn those things? Let's say you used about, let's say 34 meter cube of gases per year. So it's going to calculate your tons of carbon dioxide equivalent based on this, which is 0.06. Okay, then you burn about, let's say 4500 liters, so that comes about 12.08 tons of carbon dioxide equivalent. I'm just gonna say tons from moving forward. Then you have fuel oil. Let's say if you're burning 4500, you go up to 2800, right? So you have 19.75. And basically, if you're part of Nepal, you don't use too much of propane. Let's say about 500, because this would be the same amount of ballpark that would require 4500 liters of diesel per year. So that gives you about 21.24 tons of CO2 equivalent. If there's anybody out there that knows, okay, these numbers are not right, and the standard is, you got to go from 2018 to, if it's updated, please let us know. We'll update this in the database, right? So then it comes mobile combustion, right? Mobile combustion basically means if you own a vehicle or equipment that runs on gasoline, diesel, jet fuel, marine fuel, or different kinds of other fuels over there, you can count that as part of your GHG emission scope 1 as well. So for gasoline, we go 2000, diesel 1300, jet fuel. I don't think jet fuel is something that they burn on their own part in Nepal, but we don't have much marine, but let's say we use that fuel for alternative uses at 90, right? See, for this you need data, and to measure this you need a tool. We're gonna come to that a little bit later, but right now you just have this. Imagine that you have this, right? You're particularly going to use this if you're a part of a banker, or if you're part of some insurance company or somewhere that you already have these data, right? Scientists capture this data and give it to you. You just use these numbers, and these are very easy numbers to get, right? How many liters of fuel that you use per year, or how many kilograms of emissions that you do is okay. So this is not going to be that huge, but I know it's going to be about 230 of this size, right? I don't think we use any of R401. R401, I don't know if we use any SF6. I know methane leaks are a huge source of emission. See, now you'd think this is not a big issue. Look, if we use this much amount of 10% reduction, right? So if you build buildings that are more insulated, you use less refrigerant, meaning you emit less tons of CO2. So methane leaks, let's say 23, that adds up. So your total scope 1 emission is about 65.93. I don't want to blow this up to 300, 400, and assuming that we got to like a really bad number, because these are just 21, 8, and 35, right? So this could be like actually 12, right? We could get to 49, right? But these are numbers that I'm going from the top of my head. So since I don't have the report, I can't tell you. There could exist a factory that could do this, but I don't know. So moving on to scope 2, we have energy indirect emissions, right? So in energy indirect emissions means you have purchased energy. This is huge. I don't think anybody is going more than 2 megawatt per hour, right? You could choose location based or market based, and it's going to change your calculation based on that. Grid emission factor, you can get it from the BTR report. So basically we can go layers, we can choose our NDC or BTR dashboard and calculate that, but I know we can go with a random number right now. Let's go to, and renewable energy, let's say solar is it's about 3, because Nepal does a lot of that. So if you use 3 megawatt per hour, so other purchase energy, solar, heating, and all of that, so gigajoules per year, right? Like you utilize this from third parties. Let's say we get 23, and you purchase heat up to 45. It doesn't, Nepal doesn't purchase a lot of cooling. You do all the combustion and everything like in-house. So if you have like a bathroom where you want to have warm water, we usually have either like geyser, or you have solar. Previously, about 6 years ago, we used to have use geyser and gas, and then there was like a shortage of these methane and propane tanks, and then we basically switch to solar in our household. So right now, instead of getting like electricity through solar, we heating water using solar. So that reduces a lot of our cost. So just a one-time cost, and you just clean up the heat exchanger that uses solar energy. Let's just put this at 12, right? So you have about total scope of emission 6.45 tons for CO2 equivalent. And I know these are not right really like amazing numbers. So if you go to results right now, it shows you scope 3 is 0, and it gives you like a breakdown, like a donut chart breakdown of emission 1, 2 and 3, and gives you like a report based on percentages and all of that. So you have scope 111, 222, 333, and you can download a generate report. But we are not yet done. We have done finished with scope 2. Now we go into scope 3. Scope 3, how much do you purchase goods, right? Let's say this company spends about $75,000 on purchase good, and they spend about $34,000 on purchase services. And to business travel, they do air kilometers about 4,500, international travel about 8,300, hotel nights about 73, and rent a car distance about 3,400. You can pretty much get these from receipts of any business. If you are a CA, you can use this to calculate the um, number. So let's say how many numbers of employees. Let's say 34. Basic commute distance is about 230, and your working days per year is, we have less amount of working days, we have more holidays in Nepal. So remote work, let's say about 45%, and that gives you the most amount of tons of CO2 per task. So we're gonna see this in the results, right? So downstream activities, we sell, let's say 700 tons. Lifetime per year is about 4, and energy would be, let's say 45. So basically it gives you an idea of scope 3 emissions are the highest, always the highest, and they are the hardest to estimate. So let's see, scope 3 emissions outweighed your scope 1 and 2, guys. So it doesn't matter how much amount of production that you do, there is going to be a big chunk of, for this particular industry, scope 3. And the biggest contributor for this is employee commuting. If you did remote work, it will probably be less. But anyways, so this company does a total emission of 1031.24. You can publish this, and you can click on generate report. It's going to generate you a report on this particular report, and it's going to give you an idea. So now let us stop this tutorial at this, and I think you kind of understand this tutorial up to where how you can do GHG emissions and calculation and all of that. After this, beyond this, what we're going to do is a carbon tool selector that gives you an idea of how to get this data, right? So you can pretty much do all of the other calculations, but to get like a standard to get to up to GHG emissions, somebody's got to give it to you, right? Somebody's got to give this number to you. So if you are if you are a financier, this is something useful for you. But for someone who can calculate this and give this to you, you need that, because we are doing these numbers, right? Everything that we put here, everything that we calculated over here, these were just estimates. For this, you need to calculate that. The next video up is going to explain to you with that. Thank you so much, and hope to see you in the next tutorial.